Hey folks, welcome to my channel Number Pen. Here we have the problem on our screen. For what value of alpha is the function f of x equals x to the power 4 minus 1 divided by x minus 1 for x not equal to 1 and alpha for x equal to 1 continuous at x equal to 1, right? So we've been given a function f of x. That function takes a constant value alpha for x equal to 1 for values which are greater than 1, and for values which are lesser than 1 the function takes a value x to the power 4 minus 1 divided by x minus 1, which means in the neighborhood of 1 it still takes a value x to the power 4 minus 1 divided by x minus 1, right? So what do I mean by neighborhood? Which means as x tends to 1, what is the value of f of x, right? And let's figure out that. We know how do we establish that, right? So we have done this in some of our previous problems, and we know that all that we've been asked to establish is limit extending to 1, and this could be your right hand or your left hand limit. What is my f of x here, right? And what is my limit is one part of the problem, and we have to remember that we've been given that the function is already continuous, right? And we know that at the point x equal to 1 this function takes alpha, right? So what is x to the, coming back to limits, what is x to the power 4 minus 1 divided by x minus 1, right? So this one is again of the type a square minus b square, so I can write this as x square minus 1. I can comfortably write this as x square minus 1 into x square plus 1, and then divide this by x minus 1, right? Is this further available for simplification? The answer is yes, right? And why is that? Because I have my x square minus 1 further be written as x minus 1 into x plus 1, and this equation again remains as it is, right? And allow me to minimize. Yeah, and I have x minus 1 here, right? So I can cancel out my x minus 1. So let me pull out my pen and I do this cancellation, and I'm left with x minus 1. I'm left with x plus 1 into x square plus 1, right? That's the limit. Now for the function to be continuous at f of at x equals 1, I need to have my limits, right? My limit extending to 1 of f of x should be equal to f of x equals 1, right? Which is nothing but my alpha. Because I've been given that at x equals 1, the function takes a value alpha. So let's write that out. And what is this limit, right? Limit extending to 1, I have simplified it in my previous step. So let's copy that out, which means my limit extending to 1 becomes x plus 1 into x square plus 1, right? So I have 1 plus 1 into 1 square plus 1, which is again 1 plus 1. So I have a 2 into 2, which is nothing but my 4, right? And if, and what is my limit extending to f of x for the function to be continuous at f of x equals to 1. It has to be equal to alpha, right? So there we have the answer. So we have alpha equals 4, right? So I hope you got a good understanding of this problem. All these problems are quite simple and it basically helps you understand continuity. It's not about the complexity of the problems, it's more to understand about what is continuity and how do we examine continuity of a particular function, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.